this is a review of still integration by part. Wow, which is u, which is v? I mean, they are the same thing now, right? So I'll just pick one. Leave a lot of space and say u is equal to sine 5x, and then dv is equal to cosine 3x dx. How's that? Then du is equal to cosine 5x dx, chain rule 5, and then v here is equal to sine 3x and reverse chain rule 1/3. Why did I say 1/3 and write 1/2? God, I haven't figured out my brain yet. It works mysteriously. I mean, sometimes I ask myself, how can somebody so smart can be so stupid at the same time? Okay. Now, then this thingy becomes, rewrite, I hate this scrolling thing. Rewrite this integral, sine 5x cosine 3x dx now becomes uv. So we have, let's put 1/3 in the front. So 1/3 sine 5x sine 3x minus the integral of v du. So I'll combine the constants, 5/3 coefficients, and then we have cosine 5x and sine 3x dx. Eh? Then I'm not sure if you're paying attention to the video. I switch these u and v. This time I want this thing to be u and that thing to be v. Then disaster happens, right? You go back to exactly what you start with, so don't do that. So second, subscripts before I forget, 1, 1, 1, 1. And then now my new u is equal to negative, I'm going to include a sign here, 3, 5, 5/3 cosine 5x, and dv is equal to sine 3x dx. So du now is, this becomes positive, and sine 5x chain rule, so 25/3 dx, and v becomes cosine 3x negative 1/3. You with me? Are you with me? Anybody confused over this? Okay, and then hopefully nobody read that dumb thing called tabular integration, right? Told you not to even read it, because whatever you don't know cannot hurt you. Now, let's figure out the sine stuff, okay? We don't have to worry about distribution of this. It's already here. It's being distributed. Watch. uv, so positive 5/9. Good. And cosine. Good. Minus the integral. This is minus sign comes from the formula, and these two. And there's a minus sign. Here's a minus sign. So it becomes positive now. And then we have 25/9, right? I'm going to conveniently, this time, move this thing over and put it here. And integral of sine 5x and cosine 3x dx. So far so good? Now, and this was the trick from at the end of the video yesterday. This is equal to this, except I see the same thing appearing again. So I'm going to take this thingy and move it over to the other side, subtract from that thingy. You know what I'm saying? So 1 minus 25/9, that's negative 16/9. So therefore, negative 16/9. And then sine 5x cosine 3x dx is equal to 1/3 sine 5x sine 3x plus 5/9 cosine 5x and cosine 3x, and then plus c. You with me? You with me? Okay. Well then, I have to multiply 9 over 16. You, right? Do you know what the fastest way is? Because you have to rewrite this entire line. I know with a computer I can do copy and paste, but you don't have that option, right? Take eraser out and do that. So, oh, I have to remember what it was. So I'm multiplying negative 9 over 16, and luckily I have these things here. So 9 over 16, so this becomes minus 3 over 16, right? 3 over 16. And this thing, 9 over 16, so it becomes 5 over 16 minus sine. How about that? Wasn't that a neat trick? You get it? Questions? Okay, here's an alternative. And this is where I emphasize the trig identities. Sine, cosine. You see here even at the answer, sine, sine, cosine, cosine. You recognize that kind of pattern? Yeah, angle addition, right? Oh, see, when you have an integral and something times something, this is a hot mess, as you can see. But something plus something, you can just integrate and integrate. You know what I'm saying? So here's an alternative. Here's a nice alternative. Okay, wow. Watch this. Here's an alternative. Okay. I want to convert sine 5x cosine 3x into something plus something. Now you have to remember how we did that, right? So sine cosine pattern came out of this. You remember this trick? Somebody tell me how that thing works out? Oh, come on, people. After all that identity quiz and everything. Sine, cosine, plus cosine, and sine. You get it? Okay, and we write sine 5x minus 3x right underneath it. And it's pretty much the same pattern, except minus sign here. You remember forgetting this? 3x. And then guess what I'm gonna do? I want sine 5x times cosine 3x. So I'm gonna add, so these two cancel. So now I will have sine 5x plus 3x, I can put 8x now, plus sine 5x minus 3x, which is 2x, is equal to 2 sine 5x cosine 3x. How about that? So consequently, integral of this thingy that I wanted to do, sine 5x cosine 3. This is why the product to sum formula is a big deal. But we don't really need to memorize that formula because we know how to do this. This is 1/2 of integral of sine 8x plus sine 2x dx. You know what I'm saying? And integral of something plus something is very nice. This is cosine 8x, therefore negative 1/8, say? Say yes.
Yes.
Okay, and this will be minus 2, and then cosine 2x, therefore 1/2 here, plus c. Bang! How do you like this? Infinitely better now, isn't it? And then you're saying, yeah, but. Is it really the same thing as what we have up here? Yep, if we actually use the sum product to sum formula to convert both of this, it'll turn out to be exactly this. Or use this sum to product, whatever. They are equivalent, they are identities. but we don't have to really convert one to the other. If you have it done it that way, then you leave it. Don't try to do anything. And if you arrive here, then definitely leave it. This is as pretty as it will ever get. You with me? Questions before I move on? Okay, then. Let's do this one. What? I have a question. Will this is fifth power right here. Will it turn out to be just 1/6 cosine? Wait, those antiderivative is sine. Oh yeah, right? Sine of 6th x plus c. What do you say? Will it turn out to be that nice? But don't you wish life is that easy and simple? My daughter already resents life, right? Why is life like this, right? I don't know, because Adam and Eve got cast out of Garden of Eden. Or like, what do you want me to say? It is what it is, okay? I didn't decide it. I wish life is easier too. If you just take a derivative, there's no way in hell it'll turn out to be that, right? Chain rule is mistake. This is not like God, no, not even close. Okay, so what do we do, right? This is what we do. This is cosine force x times cosine x dx. Why the hell would you want to do such a thing, right? Well, this is same as cosine squared x squared times cosine x dx. How is it any better? Right? Now this is where it gets better. This is, what is cosine squared x? 1 minus sine squared x cosine x dx. No, you're making it worse. That's not prettier at all, right? Oh, it gets worse, watch. I'm gonna square this thingy out. So I'll have 1 minus 2 sine squared x plus sine to the fourth x times cosine x. Oh my God, you just made it the worst possible expression, right? So I took what seemed to be simple, and then I made this gigantic hot mess out of it. What are you doing? Suggestion, do you see something here? Why this is better? Somebody jump in. Shine the light upon us. Yes, Ethan.
You could distribute the cosine and then evaluate several different integrals. I know at least the first one would be easy.
With what technique? Well, first one is nice. It's cosine, so it becomes sine.
Yeah.
But what about the other one? For example, this sine squared cosine. What do you do about that?
I'm sure there's some trig identity that can make that simpler. Or you could use chain rule.
Chain rule. Not chain rule, but reverse chain rule. U is sine x. Sarah?
For the trig identity, is 1 minus 2 sine squared equal to cosine 2x, if that works, or if that helps?
No, you don't want to do that. You don't want to go there. Watch this. Du is cosine x dx, right? Let's just have a faith and make substitution and see what happens. So this is still 1 minus, my computer's, God, I had it with this computer. 1 minus 2, and this is u squared, isn't it? The sine x is u. And then this is u to the fourth a. And then cosine x dx is du. Whoa, what just happened? Magic, huh? Well, logic. Lo and behold, it was good old u sub. My God. Okay, so we know what to do now, right? This becomes 1 minus u cubed, therefore 2/3, and plus u to the fifth, therefore 1/5, plus c8. 8. And then we substitute what u is, which is sine x, so Ethan, do you have a question?
Wouldn't that first term, the integral of 1 to u, just become u instead of 1?
Oh my God. Oh my God, nice catch. That was a nice catch. So this thing becomes sine x. Holy cow, huh? Dang. That was good now, wasn't it? Okay, wow. Then this next one doesn't look as scary now, right? We'll deploy the same tactic. Yeah, let's do that. So this one, of course, is then equal to, let's say that's cosine cubed x and cosine x dx, right? Then what? We got stuck. Do you see we're stuck? I mean, you can say it is 1 minus sine squared x cosine x cosine. You know what I'm saying? If this is u, that du and that cosine is still around. So that messes us up. Dang. Okay, so this previous technique, only reason it worked is because this is an odd power. So once you separate one out, the other is even power, so you can make that trick and square it and still do u substitution. When it's even power, you separate one, then you have odd power left, and you cannot convert it into sine altogether. So this technique fails. Okay, sorry to disappoint you like that. Okay, then we have to deploy another tactic, and another tactic is this, and this is by far the worst kind of trick, the integral. Okay, here we go. Why does it scroll like that? So this is equal to first cosine squared x squared dx. Identity time. Somebody tell me what that cosine squared x is. What is cosine squared?
1 minus sine squared.
No, not that one. Half angle thing.
So 1 plus cosine 2x over 2.
Yeah, that. We kind of need that. You know what I'm saying? But while we are at it, you see this thing is being squared. Okay, so we do this. We will just like simplify the whole dang thing while we are at it. You know what I'm saying? So, can I take that 1/4 outside here? In order to, otherwise this fraction will look crazy. And then square thingy. So 2 cosine 2x plus cosine squared 2x, eh? With me? Oh, here we go again. This is nice. That ain't nice. Well, we deploy exactly same identity one more time. So this is now, here's 2, and then 1 plus cosine now 4x, eh? Oh no. Yes, okay. So that is 1/4 of, now I can combine, this is 1/2 and this, so 1/2 plus 1, it will be 3/2. Good. Plus 2 cosine 2x, and then plus, and this, I can just put it as 1/2 cosine 4x. How about that? Ready? Oh, then I dump this gigantic thingy right here. So I'm gonna put 1/4 in front. Oh, this is computer. Do this. Nice. And then change the color. Change the color, dang it. It doesn't want to change the color. Let's do it like that. dx. How about that? Okay, so it's ugly, but it's not something that you cannot handle. So this becomes 3/2 x plus, now let's just write it down, sine 2x, chain rule, oh, cancel that 2, positive, right? If I differentiate this, I get exactly that, plus, and then cosine 4x, cosine sine 4x, chain rule, so it stays positive, 1/4, so we have 1/8, eh? You know what I'm saying? N plus C. How about that? So integration by parts, right? But how, right? How is it even possible? Wait a minute. Is it integration by part? No, it's not, right? No, this is more like u sub then integration by part. Okay. Okay, so, and we right now, like, we have no idea, right? So we'll let u be, and instead of using u, because I want to save u for later, so I'm going to say w at the moment. Oh, that's the ugly w. W, which is kind of u. Okay, I'm going to call that ln r. Okay, because if this is sine u, then we have some kind of chance. You know what I'm saying? Because it's a sine ln and then backward chain rule. So it's like, it's definitely chain rule, not integration by part, because we don't even have, see, I first thought this was sine r, then ln r, but then there's no r here. You know what I'm saying? So we have to do it like this. Okay, then what is dr? This, right? Okay. There are a couple of ways to do it. We just figure out dw, right? dw is 1/r, and then the chain rule dr. You know what I'm saying? You know what I'm saying? And then, well, then once you plug it in, because we need dr. So what we have right now is this will become sine u, right? And then we need dr. Well, dr is r dw, isn't it? You see, dr is equal to r dw, but we don't want to put r dw like this now, do we? Because that r messes you up. We want that r to disappear. Okay, so it's like, dang it, right? So how do we do this? Here is where we get it. You see, r is equal to e to the w now, isn't it? Now, have you done it that way, it would be easier because, watch, dr is e to the w dw. See, we get exactly the same thing. You know what I'm saying? So instead of r, now we replace this with e to the w. Oh, did I write u here? I meant w. Really? You know what I'm saying? And now this is integration by parts now, isn't it? Okay, and this one we know what to do, right? So we'll say u is now sine w. You see why I wanted to use w? Because I wanted to save u for this. And then dv is equal to e to the w dw. So du is equal to cosine w dw, and v is e to the wa. So now this thing becomes uv, so sine w e to the w minus the integral of these two cosine w e to the w dw. So far with me? Round 2. So this is 1, 1, 1. And then my u now is negative cosine w. I want to throw that negative sign over to the u side, like I always do. And dv is equal to e to the w dw. Then du, now conveniently this just becomes sine w then, doesn't it? So wasn't that a good decision to throw the negative sign right there? And then v is e to the w. And before I forget, I'm going to finish writing the subscripts. Good. So now what we have is sine w e to the w. And then don't worry about this minus sign because it's already here. So these two now minus cosine w e to the w minus the integral of these two now. You get it? So we have sine w e to the w dw. Now let's summarize. This whole thingy is equal to this whole thingy. So I can add this thingy to the other side, eh? So I'm gonna have, therefore, 2 of sine w e to the w dw is equal to, now these two thingies, right? So we have, you know, common factor e to the w? Yeah, sure. E to the w, and we'll say sine w minus cosine w. Good. And then plus z. We just take out an eraser and divide this by 2, 8. That would be a quicker way to do this, so divide by 2. Now we're not done, because w is something that we created. We need to switch it back to r, okay? So let's go back and remember what r was. Oh, here's my r, right? R is e to the w, right? Or w is equal to ln r. Okay, substitute those in. So now, therefore, my original integral sine of ln r dr now is equal to e to the w is equal to r. So we'll have r over 2 and sine, and w itself is ln r, eh? Yeah. So ln r minus cosine ln r plus c. And I'm going to put parentheses here just to make sure that's inside. Beauty, eh? I know, huh? How about that, eh? Okay. And then I will go to number 44. This without integrating, which is 0, right? Okay, okay, here's the thing. Before I even start this, let me ask a question down here. What is integral of sine x dx from negative pi to positive pi? Can you imagine this thingy? What does it look like? Does it look like this? Turns out this is exactly 2 and this is exactly negative 2, so they cancel. That's the whole point. This is an odd function. Whenever you have an odd function, they will give you 0. if you go both sides. Exactly, that's the beauty about odd function, and this is kind of why they are the evenness of the functions a whole lot. You know what I'm saying? And then let's do another one. Say -1 to 1 of x cubed dx. Do we really need to integrate these things? Doesn't it look like that? So they cancel and give you 0 as well, right? You guys know what I'm saying. Okay. Now, what about if you have an even function? Say x squared dx. If you have -1 to 1, of course, that looks like this. Here's 1 and here's -1, right? Instead of doing it that way, you would rather want to do it this way, right? 0 is our favorite number now, isn't it? And this integral itself will turn out to be 1/3, so you have 2/3. You just double it. You know what I'm saying? So that's the special thingy about even function, odd function. Odd function being the nicest, because they tend to give you 0. And even functions, yeah, you can just double up. Okay, having said that, now we are ready. Wow, okay, we have odd function times even function. What's the odd function times even function? It's not the same thing as odd number times even number. That's an even number, but odd function times even function is odd function. You want me to explain why that is, or can you think like that? This is odd function, right? Which means this is 0. You know what I'm saying? You know what I'm saying? You want me to show you the graph of it, or do you believe it? Make up your mind. Do you want to see the graph of it, or do you just believe it?
I believe it.
Okay, sure. Okay, B, is it odd function or not? Because it's definitely not even. Cube root, 1/3 power, it could be negative, right? So this is odd as well, isn't it? This is odd. So that gives you 0. Okay, here's an even function, secant, cosine, and times odd function. So this is odd again, right? So that's 0. Oh, by the way, this has to be exactly the same distance to this both sides. Here's an odd function times odd function. Is that odd or even? What's the odd function times the odd function? Even, this is even, isn't it? So this is even function. Then this is not equal to 0 now, right? Okay. Wow, odd, even. So that's odd. This is definitely even cube is still even. You know what I'm saying? Even function times even function is still even function. So that's not 0. Okay, sine is, wait a minute, this is odd function, right? If this is a little harder to think, but now we good old trick from the pre-calculus book. If you just replace x with a -x and -x, do I get exactly opposite of this? This becomes minus this. Yep, it's odd. You know what I'm saying? And you can still check like that. Oh, I skipped that one. That is, if I switch x with a -x, I get exactly opposite. So that's odd. Here's the odd function times the odd function. So that's even function. So this is not equal to 0. How about that? Good. I mean, you can graph these things to feel it, but you don't have to feel it. You can switch x with a -x and see if you get opposite or not. I mean, there's always that trick, but I always prefer to feel the graph instead of analytically analyze it.